Hello, my name is James Pustejovksy, and I'll be talking about interpreting and generating gestures with embodied human-computer interactions. This is work done in collaboration with my colleagues at Colorado State University. The role gesture plays for an embodied virtual agent is critical. Task-oriented dialogues are inherently embodied interactions between agents, where language, gesture, gaze, and action are all situated within a common ground. And this common ground is shared by all the agents participating in the communication. In our context, we'll be examining how gesture, language, and action can all be generated and interpreted by an IVA in a situated meaning context. The platform enabling this is VoxWorld. This is a multimodal simulation framework for modeling embodied human-computer interactions and the communication between agents who are engaged in such shared goals or tasks. One of the features of this platform is the ability to enable bidirectional gesture recognition and generation. In this picture you see on the left, a human is gesturing regarding an action to move an object to the left. On the right, we have the IVA performing the identical gesture. This is the case with all the gestures that are recognized in our system. They're also able to be generated. The role that EHCI can play in how we plan a multimodal expression is critical. In fact, multimodal expressions, we believe, can only be properly planned when we have an embodied interaction that we can model. We'll look at 4 cases here. First will be deixis, which is pointing gesture, and particularly in the context of how it's generated to request information regarding how an object or a location or an orientation should be specified when performing a specific action. Iconic action gestures, which are generated to request clarification or more information on what kind of action should be performed over an object regarding a specific task. Affordance-denoting gestures, which are generated to describe how the IVA can interact with an object even if it doesn't know what it is or how it might be used. And then finally, the final nonverbal behavior is just direct situated actions, where the IVA responds to a command or request by direct action in the environment. Embodied HCI is all around us and is what we're familiar with when we perform tasks in a common space, what's called the common ground. Here, a mother and her son interact with icing some cupcakes. The situated meaning in such a joint activity is taken for granted with the way that we talk, using gaze, co-attention, gesture, and language. What this involves is the ability to identify the actions and consequences associated with the objects in the environment, the encoding of how these different multimodal expressions are contextualized given the dynamics of a dialogue. And then finally, the situated grounding of these expressions, how we capture expressions which have multiple modalities, how are they anchored, contextualized, and then finally grounded and situated in our context. The modalities deployed here are language, gesture, affect, facial recognition, and gaze. And then finally, the ability to actually generate actions. VoxWorld is the platform that enables this multimodal simulation and the creation of what we call an embodied HCI. It borrows from the 3 areas of simulation in computer science: computational simulation modeling, embodiment, as in situated embodied simulations, and then also from embodied theories of mind. The platform architecture for VoxWorld involves the IVA Diana, for example, linked to the rendering engine within Unity, interfacing with the multimodal simulation grammar, the object and habitat affordance reasoning system, other natural language and NL tools, along with various types of qualitative reasoning libraries, and then finally interfacing to a gesture and affect system. What we'll do is describe verbal and nonverbal behavior. So VoxWorld enables multimodal communication between human and an IVA. for particularly task-oriented dialogues. Human and IVA can use language, gesture, and facial expressions to communicate with each other. The human acts as a signaler, indicating objects and actions to the IVA, Diana, by means of speech and gesture. The speech is captured by Google ASR, and motion is captured using a Microsoft Kinect RGBD sensor, and these are detected in real time using a gesture recognition software package that CSU has developed. Facial expressions, actions, and gestures are all displayed on a monitor for the human to see. This was designed after human subject studies at CSU gave us, and University of Florida, gave us an example, a rich example of how humans interact with one another in order to collaborate on tasks. And so we started with human subject studies, identified what the gestures in this domain were that were needed, involving engagement and disengagement, acknowledgement, both positive and negative, deixis, and then a variety of iconic affordance and actions such as grabbing and pushing, and then iterative motion, something we call servo. So the gestures used in this human subject studies involved counting, representation, deixis, and then social speech act interactions. So we'll model a communicative act that involves multiple modalities as a tuple of essentially speech, gesture, gaze, facial expression, and action. Here's an example of a nonverbal interaction between a human and an IVA in the VoxWorld system.
Okay.
Here we see pointing to an object, essentially,
Okay.
to put it someplace else, and then a backup, undoing, putting it back, and then another deixis, essentially. She clarifies.
Okay.
He wants it moved there. There's an acknowledgement. There's another deixis, and then an
Okay.
affordance to grab it, and then another action,
Okay.
motion. Finally, there's an acknowledgement that that was the appropriate thing to do. And then she smiles in response to that. So what we have here is 34 individual gestures recognized on a ResNet DCNN, and essentially mimicking and pretty much creating everything that we had with the human-human studies. These are some of the gestures used in VoxWorld that we just saw. They're not only recognized, but also generated. The facial expression and gaze. Facial expression feedback is a challenge. Diana has the following expressions. She's got the basic Ekman classes: smile, frown, sad, frustrated, neutral, and concentration. And she accommodates directly in terms of the user's gaze, depending on where the user is directing the gaze. Diana uses the appropriate response depending on the expression. So here's just some of the basic range of the expressions Diana uses to react to an agent's affect. This is how it compares in the action unit code to the other Unicode combinations. Details can be provided in the paper. Finally, we look at how the VoxML, which is one of the languages used in VoxWorld, allows us to encode affordance information and object geometry information. Here, for example, is the representation of a cup. This gives rise to affordance and habitat information that the IVA can use for learning how to manipulate an object, given the types of gestures and actions that she has available to her. So it's, for example, a situated gesture sequence command. Here we saw something similar to this in the video. We have a deixis, a moving, and another deixis to put it there. This is essentially a single modality imperative: point to a block, make a move gesture, point to where it should go. This is the gesture generation for performing that complex action. And we have similar abilities to essentially recognize affordance-denoting gestures. In conclusion, I'd like to argue that embodied HCI involves situated grounding of communicative expressions in all these different modalities, including language, gesture, facial expressions, gaze, and action. Embodied HCI enables bidirectional gesture capabilities, and VoxWorld as a platform facilitates this experimentation with IVAs for recognition and generation of gestures. Thank you very much.